Hi everyone, we are back and we are about to do our two-way ANOVA. So we have started to look at fertilizer, now we're going to look at density. And when you do a two-way ANOVA, our equations that we've gone through last time in terms of how to calculate it get a bit more complicated because we have to account for different A and B variables that each have different different variables that have different treatments. So basically, we saw that with the fertilizer, it was 1, 2, 3. For density, it's going to be 1 and 2. So we see different, different treatments, different conditions. So we can kind of see that we're going to get two different F ratios. And we're going to also look at the combinations of the two, and the degrees of freedom will change as well. So we can go through these, but we went through these last time. You can kind of double check how to calculate on your own. But let's go ahead and let's actually start to just run it in our ANOVA test. So let's go ahead and let's get at it. So we've done one way. We've done our games howl. Let's go, and we actually did our eta squared as well, even though we could calculate that one ourselves. But let's go ahead and let's go look at, I'm going to go two-way. And I'm going to look at now AOV, ANOVA, and we're going to look at our crop dat, and we are going to look at this time now, actually, excuse me, we're going to look at yield and how does it vary as a function of density plus fertilizer, plus density and fertilizer as a basically a function of each other, combined variable. Fertilizer. And then our data is equal to crop dat. And we can run it. Oops, let's go ahead. We don't want den, we want density. Dense. All right, so we can look at, again, our summary of our two-way. And we can see, all right, let's analyze this table here. So we can look at the degrees of freedom for density. Makes sense because if we look back at our crop data for density, we have just 1 or 2 for our, basically not our variable, but our, experimental conditions. Fertilizer, there's 2 variables, the density of the 2 because they're combined variables, and then we have our total degrees of freedom. Sum of squares, again, we've calculated those values, but now we can look at our F values, but more importantly, we see that fertilizer, as we found last time, is statistically significant. So it's a statistically significant parameter in terms of the outcome on the yield. So is density, because it's less than our 0.05. However, we see that density and fertilizer as a combined variable is not. So that is not necessarily an issue, but we can kind of see those differences. Excellent. So that's quickly a two-way ANOVA. So afterwards, the next video, we're going to look at our games HAL test for the two-way ANOVA, and then we'll look at our eta squared, and we'll see what values we kind of want to see. But we can also look at this actually quite quickly. We can also, we can do something like we've done previously, which is we can look at and plot our, let's look at, confirm this. Let's look at, instead of fertilizer yield, we can look at dense, I believe it's dense. And then we can look at dense here, and we can see statistically significant. So let's confirm that next time with our games HAL test and see if there's some differences, but it's looking good so far. See you then.